In this course, we will be learning about the tool HYPERMESH and the solver Radioss. HYPERMESH is a universal preprocessor that is widely used in the industry. Radioss is a flavor of NASTRAN and is the most preferred solver for structural analysis. This course features 60 hours of classroom sessions, 200 hours of practical sessions, topic-wise online tests, 60 hours of industry-oriented project, and special sessions for interview preparations. Module 1 will consist of geometry preparation and meshing techniques using HYPERMESH. This will include geometry preparation of auto and aero systems using HYPERMESH, under which we learn about the geometry preparation for the fender of a car, geometry cleanup for the center pillar of a car, and the geometry preparation for the wing panel of an aircraft. We will later move on to 2D meshing techniques for auto and aero systems using HYPERMESH. This will consist of meshing of BIW parts for both auto and aero using auto meshing techniques, and meshing auto and aero components for crash and durability analysis. We will later move on to 3D meshing techniques for industrial systems using HYPERMESH. This will consist of 3D meshing, structured meshing consisting of brick or hexa elements, and unstructured meshing consisting of tetra elements. We will also learn about 3D mesh generation for industrial systems. At the end of the module, you will have assignments and evaluations on geometry and meshing. The topic for Module 2 is structural simulations using Radioss. Under this, you will learn structural analysis for aero and automotive systems. You will learn industrial approach to design and validation, introduction to FEA and CAE workflow, and introduction to strength of materials. You will then move on to linear static analysis, both theory and practice. Here you will learn about the design validation of an automotive gear shaft using structural analysis, identify the failure mode and redesign an engine mount using linear static analysis, and design a connecting rod for strength using stress analysis. You will also learn how to process results using HyperView. You will finally learn how to interpret and document results. Under Module 3, you will learn about the advanced geometry and meshing techniques using HYPERMESH. You will learn about meshing techniques for plastic parts using HYPERMESH, under which we will learn about mid-surface extraction and meshing of plastic components, mid-surface extraction and meshing of BIW sheet metal components like chassis, etc., 2D mid-surface meshing, a door trim with doghouse joints, mid-surface meshing for chassis frame, and 2D meshing generation of automotive and aerospace systems. You will learn about mesh generation techniques for stress or durability analysis, and you will also learn mesh generation techniques for crash analysis. In Module 4, you will learn thermal and dynamic analysis using Radioss. You will be introduced to normal modes of vibration, under which you will learn solution methodology, which consists of eigenvalue, eigenvector and Langsource method, normal modes analysis of mini racing car frame, vibration analysis of a rotor, natural frequency estimation of a truss bridge, and modal analysis of a brake disc. You will then be introduced to thermal analysis, wherein you will be doing a thermal analysis on a friction ring. In Module 5, you will learn about assembly modeling and meshing using HYPERMESH. You will be introduced to solid editing, and then you will create mappable solids for 3D meshing. Under this, you will learn 3D hexa meshing techniques for sphere, T-pipe, block with cuts, 3D hexa meshing of door hinge bracket, 3D hexa meshing of a control arm, and brick meshing of a solenoid body. You will then be introduced to 1D elements, types, applications, bar, beam, and rods. You will learn to mesh through 1D meshing of SAE Baha frame. We will later move on to 1D elements, advanced RBE2, RBE3, and its applications. You will then move on to using 1D elements for connections, bolts, and welds. We will then move on to types of connections in assemblies. We will learn through assembly meshing of a wing box with shear clips using bolts, spot weld generation using connector tool, seam weld generation for chassis frame using connector tool. We will then move on to introduction of CFD meshing, under which we will learn CFD meshing of exhaust manifold. Finally, we will learn how to export case files for Abacus, LS-DYNA and FLUENT solver. Module 6 consists of buckling and non-linear analysis using Radioss. You will first be introduced to non-linear analysis. You will then be introduced to solution methodologies for non-linear analysis. Later you will continue on to types of non-linearities, and under non-linear contact analysis you will learn through analysis of aircraft wing box using gap elements, modeling contact pairs for a typical 3D bolted joint, and non-linear contact analysis for a chassis subframe. You will then be introduced to buckling analysis, and later analytical solution of buckling of columns. You will finally learn to prevent the collapse of piping systems using linear buckling analysis. You will also receive a value-added module free of cost. You will be introduced to Ansys Workbench. You will learn how to import a geometry, how to create a CAD model, and you will also learn the GUI of Ansys Workbench. You will also learn modeling, under which you will have geometry preparation for the fender of a car, introduction to design modeler, 2D modeling where you will learn plane, sketching, modify, dimensions and constraints, and 3D modeling where you will learn extrude, sweep, revolve, loft and skin. You will learn geometry cleanup using design modeler, under which you learn geometry preparation for the fender of a car, body operations, slicing operations, boolean operations. You learn edge connections, face merge, face split, surface patch, surface flip and projections. You'll also learn repair tools such as freeze and unfreeze. Later we'll move on to mid-surface extraction and editing using design modeler. We will then move on to 3D meshing, where you will learn linking mechanical module to geometry, global mesh controls and local mesh controls, tetra meshing of solenoid and element shape checking, sweep meshing, multi-zone meshing and map face meshing controls, linear static analysis of impeller assembly, under which you'll have applying loads and boundary conditions, using coordinate systems, running analysis and post-processing. Normal mode analysis of machine frame, where we'll be introduced to normal mode analysis, solution process for normal mode analysis, analysis settings and solving, and extracting various modes of vibration.